to give you an understanding of where these things fit. So we have traditional host-based OS, host OS-based virtualization, and this is where the virtualization product actually sits on top of another operating system. And this is an example of, say, running XP on Windows 7 or running Windows on Mac OS X. The machine boots into Mac OS X or it boots into Windows 7, and then you're running another operating system on top of that. This is sometimes called a Type 2 hypervisor. And then we see the hardware partitioning or OS partitioning technologies. And these are primarily Unix or mid-range systems, and this is where the operating system is capable of carving itself up to present different versions of itself to different users or different applications, or the hardware itself is electrically capable of being isolated individual components such as processors and memory and network components, so that each one of those electrically isolated components or areas can run its own operating system. And that's hardware partitioning and iOS partitioning. And the flavors there are containers. So for instance, Solaris containers are examples of OS partitioning, and Solaris LDOMs are an example of hardware partitioning. And then we come to the more common environment that is very important today, as you'll see, with regard to cloud computing. And that is the hypervisor-based, or traditionally hypervisor named type of virtualization. This is sometimes called a Type 1 hypervisor, and this is a small piece of software that sits on the hardware itself that the OS are installed on top of as virtual guests. So an operating system is stored in the traditional sense on top of the machine, but a virtualization layer called a hypervisor is, and then this allows you to create logical software components called virtual machines or guests, and these are into what the operating systems that you're wanting to use are installed. And the advantage of this effectively is that you use commodity hardware, but you get very good isolation between the virtual machines. You get very good utilization of the equipment underneath. You get access to fine-grained resource controls, and you can mix and match operating systems and versions with a great level of freedom and get the maximum performance out of the physical hardware underneath. So the key components of a server virtualization platform, we obviously have to have the machines themselves. So they're still physical computers. The physical computers are installed with the hypervisor software, and this become virtualization servers effectively. Once you have a series of virtualization servers, you need to connect them all to shared common storage so that they can all see the same disks, so that they can all work with the machines and the same data files. And this shared storage can be NAS or SAN or iSCSI, some level of high-performance networked shared file system. Using these two components, you're able to create pools of servers. You arrange the physical machines, the server, the virtualization servers into physical pools, which you call server pools. And server pools are able to run any of the virtual machines in the environment. You're able to load balance across those physical machines so that your virtual machines, when they're running, take advantage of the best resource inside the environment. And of course, you have to have some form of centralized management to make sure that you can look after all the virtual machines, the physical servers, and the server pools themselves. And these components are common in one way or another across all of the mainline virtualization environments today. Now, the key benefits of server virtualization over and above the ability to consolidate machines into allowing you to use reduced numbers of hardware to support the same number of workloads, the ability to provide a very flexible environment, and so on and so forth. The key benefits of server virtualization with respect to cloud computing, which I'm going to come on to, are actually live migration and high availability. These are two technologies that are relatively recent. They have completely changed the nature of computing in the modern environment. And these actually allow you to take completely running operating systems, applications and workloads with their full user stack, all the live connections and active workloads, and move them from physical machines to other physical machines in different environments without any interruption to service. And the high availability functions. High availability functions, this means that you can actually set up an environment of machines such that if one of the physical machines crashes, the virtual machines can automatically get restarted elsewhere without having to have any manual intervention from users or operators. So you can ensure that a service level is maintained to its end users such that a virtual machine, if it goes away, it will come back again very quickly, irrespective of the failure of the individual physical components underneath. So these two components are actually essential to the development of the cloud, which is commonly. So moving into that, what is cloud computing? So cloud computing has many different characteristics, and this is the Wikipedia definition, which is as good as any for giving you a common definition of what cloud computing is. But essentially, the one defining feature that all cloud concepts exhibit is that they offer some facility accessible via a network on demand when it's needed for some usage-based fee. That's the basic concept behind cloud computing. That's the business model that the cloud computing providers are trying to take and provide as a service, and that's the advantage to the end users encapsulated in that. They can basically take and use components, resources, software, or applications as they need and charge for what they need when they need it. And it's the advantage for the supplier to provide the best and customer community for its installed base of hardware and software. So what does cloud mean to you? So as a consumer, it allows you to take advantage of virtualization technology without worrying about the underlying components themselves. So you don't, I know I've just gone through virtualization, and you can see there's large arrays of different types and different complexities, many different products. This potentially is a very confusing and complex environment. Cloud computing actually allows you as a concept, as a consumer, to take advantage of all those facilities of virtualization without having to know about the details themselves. You can just rent some facility for the time you need it to provide the services you need. All you need in order all you need to do in order to use that is just select a cloud provider that runs your facilities to the service level and the price that you're happy with. As an implementer, the cloud technologies give you the same sort of advantage. It allows you to mix and match the most appropriate underlying components to your needs, costs and service levels. By their very nature, you don't have to rely on a single provider or the components themselves as the cloud technologies manage the facilities across the resources itself. So it actually allows you to pick the best breed, best components that suit your environment, and the cloud technologies help merge all those together to provide single functions. So you've probably heard of cloud. You think of, say, Amazon EC2. Amazon was the first public cloud vendor that came into public conscience, and it provided a facility for